to help go through it and to give some other things, right? So we're going to learn how to use calculator, right? Then everything else is stuff we've done before, right? And we're going to calculate the p-value using technology. We weren't able to notice we only used the critical value method when we had the t-distribution. I couldn't tell you exactly what p was. I could just tell you it was less than 5 because we know what value corresponds to 5% or 2.5%, right? So quickly answer these. Write the answers down here. I normally don't have you do this, but try to write them down both in words, right? Null hypothesis, write symbolically, blah, blah, blah equals blah, blah, blah. And also in words. There's also a second question here. Null hypothesis here, everybody. Null hypothesis always involves what sort of sign? An equal sign. And here, right, we're always making, as Bobby said, we're making a claim either about a proportion or one about a mean, right? In this case, it's the claim about a, everyone, this is pretty easy, mean. So we're claiming the null hypothesis is that mu equals 200. The mean caffeine intake of college students is 200 milligrams. And in this case, the alternative hypothesis is that it is greater than the alternative hypothesis. Okay. Now, this one's not too hard. You take a dice out of a board game box, you roll it 10 times. Each time you roll it, you get a 6. What does common sense tell you about the dice? The die. You all have this common sense. You're all suppressing it right now if you can't say it. What does common sense tell you about this dice? If every time I roll it, I get a 6. That something is wrong with it. In other words, fixed means what in probability terms? The probability of rolling a 6 is not 1 out of 6, right? We think that it's higher than it, right? And so let me tell you what if you didn't notice this is a hypothesis test in a sense, right? So you can calculate the probability of rolling 10 sixes in a row. It's about 1 in 60 million. So if you take a dice out of a board game box and roll it 6 times in a row, there are 2 possibilities. 1, the dice is not fixed, and by random chance, a very unlikely event occurred. Or 2, the dice is fixed, which is in another way meaning that you're rejecting the assumption that the probability of rolling a 6 is 1/6. Because the event that you saw with your own eyes is very unlikely under that assumption, right? So that is exactly what you're doing, right? This assumption is your null hypothesis. You are rejecting the null hypothesis because your sample is very unlikely to have occurred given that under that assumption, right? And how likely is very unlikely? Well, that's the significance level. I didn't tell you a significance level here because it didn't matter, right? No matter what significance level you were going to use, this was going to blow it out of, right? This is mini standard deviations too high. Do we understand what this is illustrating, right? If something is, when you make that assumption, the dice is rigged, you were saying the common assumptions, right? When you took that dice out of the bag, you did not assume it was rigged, right? You had an assumption about what common sense tells you the probability of rolling a 6 is 1 out of 6, right? But when you rolled it, when you had something very unlikely occur, given that assumption, you rejected the assumption, right? Does everyone see that that is what a hypothesis test does? It assumes a particular value, right? In this case, you'd be assuming the mean caffeine intake is 200, and then you're seeing the data that I have, how likely is that to have occurred under that assumption? If that likelihood is underneath my significance level, I reject the null hypothesis. So just a quick difference, right? Here's an example of null hypothesis. All right. This we don't use. Some textbooks, right? If you're looking at resources online, sometimes they have their null hypothesis using greater than or less to than. It's actually the same thing. It's just conceptually different. We're just going to always say that it's equal to. I think that that's better for y'all. So if you just see something that says something else, just convert it to equals to, okay? In this class, we're always going to say equals to. It ends up not mattering, but it's not a big deal, okay? And that's the note there. Okay, so let's do this together. Let's all say, all right. So this one right here, we had done this one right here, the test. Everybody, is this a test about a proportion or a mean, everybody? Proportion, and the null hypothesis in this case would be that P then is equal to everybody just look at it. And the null hypothesis is going to be one of three symbols: less than, not equal to, or greater than. In this case, it is less than. I don't know how I came up with this one. A study is done to see if eating beets affects reaction time. I do know from a family member that eating a lot of beets can affect urine color. I'm not sure about reaction time though. All right. So this one, a test about a mean. This one's or a proportion. Mean in the null hypothesis in this case is that, and then this one's a little bit harder. What is the alternative hypothesis in this case? Not equal to. Yeah, the not equal to, because we're just saying, I think it affects it. I didn't tell you whether I'm not testing, I'm not claiming that it makes it better or makes it worse, right? Okay, requirements. So for proportion, simple random, NP is greater than 5, and NP minus 1, aka N. What's another name that we've used for P minus 1? Q. Both are greater than 5. That just basically means like, hey, if it's a proportion, right? If I want to see what proportion of people prefer vanilla to chocolate, I need at least 5 who do and 5 who don't, right? Almost all, if you have any large sample size, right, you're probably going to have this. Claim about a mean, we just said this, right? Greater than 30 or normally distributed. So here are the steps again. I'm going to kind of break it down, all right? This is going to be the calculator. So state the original claim, right? Determine the null and alternative hypothesis. I decided to break it into two. Before what do I also say you have to determine at this stage? The alternative hypothesis will help you determine what type of test you use. And when I mean what type, I mean what type of, boom, yeah, what type of tail. You also have to identify this to be able to get going. Yep. Now, I'm going to add another step here. Because before, right, each section we were talking about the same thing, right? So here you have to know what type. So before I would say calculate the test statistic. But sometimes your test statistic was Z. Sometimes it was P, right? So when it was a proportion, we always used a Z, or did we use a T? So when we did proportion, did we use a Z test or a T test? Z, right? And now, remember, again, I said the standard deviation unknown, it is a T test, right? Standard deviation known is a Z test, right? This one, I'm not putting all the steps before because we're also using, we're going to do with a calculator, right? So you want to identify the given information out of the problem, right? So you need to know, okay, what's the sample mean, sample size, right? If you're doing a mean, right, you need to know sigma if it's known, and if it's unknown, you need to know the sample standard deviation. You need to identify that. If it's a proportion, it's much easier. You just need to know the sample proportion, the sample size n. We're going to now learn how to use our graphing calculator to calculate your p-value and test statistic. Interpret the value of p, say it's what the probability of. Since our calculator can do both, we're kind of simultaneously using the critical value and the p-value method simultaneously. Right? This is the p-value method. You're going to make your conclusion whether to fail to reject or to reject the null hypothesis, right? And you're going to do that when p is less than alpha, right? That was the p-value method, right? Okay. So Frank is an intense sports dad because he's timing his son's swims at age 8, which doesn't seem very healthy to me, but whatever. I'm not a parent, so what the hell do I know? Okay. So Jeffrey is an 8-year-old, right? He can swim the 25-yard freestyle. His mean time was 16.43, right? And the standard deviation is 0.8 seconds. Frank thinks maybe, let's see if he can swim faster with, he wears goggles. I could see some theory by that, right? I don't know exactly why. And then, so he then has Jeffrey wear the goggles, and then he does 15 swims with the goggles on. In the 15 swims with the goggles on, Jeffrey's mean time was 16 seconds. And Frank thinks, okay, that's a lower mean than it was before, right? So he's saying, I think these goggles help, and he wants to do a hypothesis test with a significance level of 0.8, right? And these aren't, we're going to assume that that we're dealing with normal distribution, so we don't have to worry about the requirements. So what's the original claim here? What is, usually the original claim is what the person doing the experiment thinks. And faster than, okay, so that is less, that sounds less than. We're talking about a swim time, so is that a mean or a proportion? Absolutely. And faster than what? Boom, absolutely, right? Now, what's our next step? We have to state the, yep, so the null hypothesis in this case will be, yep, and the alternative is that it is, okay. Then next we have to know what type of test to use. So we need to think about, is this a, what are the possibilities when we're thinking about tails? This is left in this case. The possibilities are left, right, and 2, and this is left. And Regina, how did you know that? Yep. Because it's less than, right? Then before we jumping in, we need to know the significance level, right? That the word, right? Okay. And that's 0.5, right? So then you need to basically identify what type of statistic are we using. Before, I'd always given you, this is a problem about a proportion, right? That was a whole section. Then it's a problem about a mean, right? I'm not going to, you're going to have, you may have noticed on your take-home celebration, you might have, you're not going to know whether it is ahead of time. So you have to identify this. Regina, you told me this. This is a problem about a mean is correct. Now, if it was a proportion, you always use a z-test, right? For a mean, do you always use one test or the other? That's a confusing question. Just because it's a mean, do we know whether it's T or Z? No. Okay, this one's weird. So it's very I want you to point out. Okay, so this standard deviation right here, is this a population standard deviation? Seems no, but let's think about this. So usually the population is very large, right? So Frank is a very intense in sports dad. His son is only 8 years old, which means he can't been swimming for that long. So what has Frank done? He has recorded every single practice of Jeffrey, right? He's written those all down, and he has taken the mean and the standard deviation. The population here is small enough, right? So that's the population of all the swims without the goggles, right? So this is actually a population standard deviation. Do we see that? So very unusual, right? But he has enough of these swims that he's collected the population. So in this very unusual case, we do know the population standard deviation, meaning that this is, yes, this is z-test, okay? And we needed the needed info. So the needed info here is, well, it's the stuff in the formula, right? So the stuff in the formula, you need your sample mean. What else do you need to know about your sample? Say again. We have it. Doesn't it depend on the sample size? And you need whatever standard deviation you have available, right? Okay. So now we're going to calculate the p-value in the test statistic using our calculator instead of by hand. So you know the variety of tools that are available to you. Okay. So you can guess maybe the first button you're going to hit is, as a whole, what's the name of this class? So you're going to hit stat. You can guess what menu you think it's going to be under. Yeah, it's a statistical test, right? So, and which one are we going to use? Z-test. Notice it says you can, so if you have a proportion, right, use option 5, because notice this says Z for one proportion test. You can do it with the regular Z-test, but then you have to calculate the standard deviation by hand using that formula. So, right, just let me show you with that, right? So notice if you use the proportion test, that's 5. You just have to enter in this information, right? But now, that test, Z-test, notice there are 2 types of inputs, right? Data and stats. So if you had raw data, like if I just listed Jeffrey's swim times, you would go to data and you would have to make sure your data was listed in L1. Everyone remember putting data into our list on our calculator? Okay, so we're not doing that. This is a little bit easier. We're doing stats. So you go over to stat. And then you just have to fill in this information, right? And you can notice we ask us our standard deviation because we have that known, right? If it was in the t-test, it would not know this, right? It would ask you for S. It says S sub X, that's the same thing as S, all right? We cool with that? Okay, so let's put in our information. So this is kind of weird. It's asking, this is for the alternative hypothesis. This is the null hypothesis. So null hypothesis is always equals something, right? So it's just asking what's the equals value. So what do I put in here? Y6. Yes, I think you're the first person who said 60 for 16.43, but that's all good. All right, and then sigma is 0.8. X bar, 16. N, 15. Less than. You can hit draw if you want to see it make like a normal distribution curve and show you the whole picture. But we don't need that here. I'm just going to write calculate. And notice, this is our test statistic. This is our p-value. Let me just remember us interpret this. So I could use my z-table to get the critical values, right, if I want to use the critical value method. But since it gives me my probability, it's much easier. So now that I have this information, I need to decide whether to accept or reject the null hypothesis. Or sorry, not fail to reject. I keep saying that, right? So let's interpret this p-value. So this p-value right here is saying the following. If the goggles don't help, if this sample isn't different than his regular sample, the probability of that, right, the probability that this would happen by chance is 1.87%. So the decision, our p-value, when we do the p-value method, which is the easier method to be honest, we compare the p-value to the, and in this case it is less than the significance level, which means yes, right? That means a low probability of this happening means the null result, there is no difference, is unlikely, right? So a small percentage, right, means you reject the null hypothesis because you found a sample following common wisdom, right? Following whatever is unlikely. So in this case, your decision is to reject the null hypothesis. So if you want to state the conclusion in your own words, you would say, do we want to say there is sufficient evidence to support or the evidence does not support? What do you want to say? Yeah, I wrote it a little bit different, and we want to say that, and what's the claim here, like in regular people words? So the claim was that the mean was less than a certain value, right? What does that mean about like the story? So what's different about what did Frank think caused this lower mean swim time? Yes. And not just specifically on the swim time in any direction, right? That could be a hypothesis, but that it helps them swim. And I didn't do this before, but it's good, right? If I wrote this sentence without this and you didn't have the test next to you, right? If you just read this in the newspaper, you would want to say how strong is the evidence, right? I just said it supports. So it's good to quote the significance value in here. I'm not going to be a stickler because the significance value is always going to be written on your test. But if you were writing this, if you were writing an email to your boss, I don't know why you're writing it about this, but about something else, right? You would say, hey, I tested your claim. And he's not a math guy. He hasn't taken this stats class. You would just say, here's my significance level so he can know how strong your evidence is, right? This problem's kind of contrived in some ways because you would actually have access to the population, but let's just suppose you don't. So statistics students believe that the mean score on the first statistics test is a 65. The instructor thinks the mean is higher than the 65, but like this isn't SXU. This is U of I, right? So he doesn't have all the students' test scores. He only has a simple random sample of 10. And we're assuming the data is normal. We need to assume because we wouldn't need to assume that if n was what or more. So n was more than what? 30, right. Okay, so he thinks that the mean score is higher than 65. So first I need to state the, well, what's the claim, right? That's what we need to state. It's higher than 65. So the original claim is the claim of the person in the story. Yes. It's very hard to test, right? Like you can't really test the probability that something's exactly 65. That's not possible, right? But I could see why you would think that, right? I just want to mention that. The probability that any continuous variable is exactly some number is infinitely small, right? Okay. But now that we have the original claim, everybody, we need to know the in this case, the null hypothesis is that, yep. And everybody, the alternative hypothesis here is that it is, everyone do it with your hand. I'm looking in the wrong way. Yep, greater than 65, right? Which means, yep. And before we start jumping into our calculator, we need to know that, yep, 0.5. So what type of statistic helps us decide what test, right? What type of statistic is, or parameter, right? What is this a claim about? Which two things, the mean, right? And with the mean, before we don't know the test until we determine if what? If the population standard deviation is known or unknown, in this case, it is unknown, right? Meaning, all right, now the needed info we don't have, but our calculator can find out because we literally have the sample, right? So let's show us how to do this. You could calculate it with your calculator and then plug it into but you could skip a step doing that. So let's just remind ourselves how to do that. Okay, so second quit. Let's go to stat. And then remember, we have to enter in our data. I already have some data, right? You might have some old data in there. Remember how to get rid of this? Second, memory. Option 4 clears all lists. You could also just write on top of it and delete one at a time. One thing you don't want to do is go up here and hit delete. You will actually delete, like, not the data in the list, but you'll delete the column. Like, we'll go from L1 to L3 in this case if I do that. I have no idea how to fix that other than reset the whole memory on your calculator. I don't even know why that's something that they allow you to do. Like, that seems stupid to me. Okay, so now let's enter in the data. So let me just tell you what the test scores were. It was 65, 65, 70, 76, 67, 66, 63, 63, 68, 72, 71. Okay, now that the data's in, we're going to go back to stat. Where do I find this, Bobby? It's going to be stat and then test. And this time I'm going to be doing option T because I don't know this, right? Now here, I don't want to do stats because I do not have the stats. Instead, I have data. collect data. The frequency is confusing. Your frequency, you always want to be L, just make that 1, okay? Just make that 1. Since the list is in L1, that's great. I could put the list in L2 or L3. We're not going to be doing much where you use more than one list at a time, so just put it in L1. Now, the one thing that's not in the data is what it thinks the population, right? So what do I need to type in for that first number? Null hypothesis, right? The null hypothesis was that the population mean is and this time the type of greater than. Now we don't need to put in our significance level. It will just tell us the p-value and we have to interpret our result, right? Okay, so we now have our t-value and our p-value. Now, on the homework, right, for the t-test, so sometimes it gives you a like an output from something called StatDisk. It's different than the calculator, but you can read it, right? If you can only do the p-value method for t-tests using the calculator. There's not a way to do it by hand, right? So if you have to give if you look at a problem, right? If it says, you know it's a t-test and it asks for the p-value, not just reject or fail to reject based on the critical value, you need to use your calculator. Everyone following? Okay, so here's the t statistic. Let's write these down. So the p-value was 0.3, 0.03, yes, 0.0396, and the t-value is 1.97. Okay, so you can interpret this, right? If the mean score is really what's in the null hypothesis, there's a roughly 4% chance that the mean of 10 students would be as high as this sample. So our decision is to, what do we want to compare our p-value to? So it's less than the significance level, which means fail to reject or reject, everybody. So what that means is the evidence supports the claim that, exactly,